very important for cloud formation. And there are different types of aerosols. And so PACE is going to have two polarimeters looking at our atmosphere. And these aerosols are really critical for climate regulation. And it is one of the biggest uncertainties we have when we look at climate models. And these models are really, really essential for us to be able to understand where we are now and where we're going into the future. So PACE is really going to be able to help us better constrain our climate and understand what we should expect.
Right. Thank you so much for answering that question, Laura. We have another one coming to us from Instagram. Armando_305 on Instagram asks, will these studies help us learn more about red tides?
Excellent question, Armando, and absolutely. So PACE has one of the other, and it's the key instrument that PACE has is the ocean color instrument. And as the name indicates, it looks at the color of the ocean, but it looks at it in a way that is hyperspectral. And every phytoplankton, and these are the small algae that live in the ocean that are the base of the food web, they have different sizes and shapes, and they each absorb light differently. And this is like a fingerprint. And so by knowing what kind of species are there, because this is what PACE is going to enable, we're going to be able to know which is a good phytoplankton, which one is a misbehaving phytoplankton. And this is going to help us then better understand the distribution of harmful algal blooms and also predict where they might occur.
Right. So, I mean, people online really want to know a lot about these tiny particles, these phytoplankton. So, Con Savvy on YouTube also sent us a question. He says, what kind of data does the phytoplankton on the surface give?
So basically, it's light what we're looking at. And so this, again, these very particular light signals, the color is what we're going to be looking for. And we're going to learn more about that as we share this morning with you.
Exactly, yeah, a lot more to learn about these tiny phytoplankton microorganisms that live in the ocean. So clearly there is a lot to unpack. There's a lot to know about this PACE mission. We ask that you please continue to send us your questions using hashtag AskNASA. But because there is so much to learn about PACE, Laura and I won't be the only ones that you hear from today. We also have NASA's Megan Cruz standing by at a nearby launch viewing location to introduce you to some of the key people behind this mission. But first, let's check in with our launch commentators, Daryl Nail and Mick Woltman over at Hangar AE.
Thank you very much, Jasmine and Laura, and welcome into Hangar AE. I'm Daryl Nail, joined by Mick Woltman, guy who has 30 years plus of experience in the rocket industry, so we're glad to have your expertise here. Let's talk first about the weather. It was a big deal the past few days. In fact, it canceled a couple of launch attempts for the first two calendar dates that we had. Low pressure system came over the state, lots of wind, too high to go. But in the end, on the third day, well, we had nearly perfect conditions. We are more than 95%.
Yeah, more than 95%. Absolutely. The last couple of days, it's been a 60+% possibility violation due to the weather. But as you said, it is cleared tonight. The weather looks really great. Launch weather officer briefed us just a few minutes ago, and everything is absolutely perfect for a launch early this morning.
And there's a look at the rocket and the spacecraft on Space Launch Complex 40 out there at the Space Launch Complex, 40, a slick 40 as they like to call it. And you'll see the spacecraft at the top of the rocket. The booster is reused. We'll get a little bit more into that later on, but we are getting ready to flow propellants into the rocket. You can see some of the condensation from the tank farm for the liquid oxygen kind of blowing around there. We don't have any propellants in there yet, but we're about to go. You mentioned the weather. In fact, they dropped the weather brief that they do shortly before going with the propellant. So it's that good out there, folks. Let's talk a little bit about the trajectory. This is the first time in 60 years that we're getting a Cape polar trajectory going out of a mission with NASA.
Yeah, absolutely. We're going to be taking this Cape Polar trajectory, which is unique, and we're going to hear about that a little bit later.